Okay, we're going to start a new unit about chemical reactions. In order to understand that, we got to first learn about conservation of mass. So conservation of mass says that matter, which are made out of elements, cannot be created nor destroyed in a chemical reaction. So basically, this means that the sum of all the reactants has to be the sum of all the products. This means that whatever you start with in grams has to equal whatever you end with in grams as well. Okay, so you're going to add up whatever you have started in your reactants has to be equal to all of your products. So I'll color code this. Your reactants must equal all of your products. So if you have a chemical reaction, such an example down here, what are your reactants? Your reactants are anything that is before the arrow, and then your products are anything that is after the arrow. And so now let's read the question. It says 10 grams of chlorine, and we see how this chlorine should be in purple or pink here because it's before the arrow. And it says it reacts with 5 grams of aluminum fluoride. This is also before the arrow, so this is also a reactant. It produces 12 grams of aluminum chloride, which is a product. So I'm going to color it green. It asks how many grams of fluorine are also formed as a product. So basically, you're going to match these numbers and pieces of information, this 10 and 5, and this 12, and then we have a missing number here with this chemical reaction. So you're like substituting, right? So here, 10 is going to replace the first one, 10 grams. So this chlorine here, it reacts with how many aluminum fluorides? 5 grams here. You got to think of this arrow like an equal sign because they have to be equal on both sides, right? And you're going to replace the AlCl3 with 12 grams plus, and we're missing this number right here, which is F2. We don't know how many grams is here. So now you solve for like you're missing X, right, in algebra. What is 10 plus 5? It's 15. So you have 15 grams equals 12 grams plus some unknown numbers. How do you get 12 to the other side? Okay, what the opposite of addition is subtraction. So 15 minus 12 is, the question mark is equal to 3 grams. You do a quick check. 10 plus 5 is 15, which is on the left. 12 plus 3 is 15, which is on the right. So now they are equal. Okay, you can see these asked in multiple different ways. So let's look at the second question. It says 25 grams of chlorine. So once again, this number is at the beginning, right? And so this number is part of our reactants. Reacts with aluminum fluoride, right? So all of this is about the reactants. It produces 35 grams, right, of aluminum chloride and 7 grams of fluorine gas. It wants to know what? How many grams of aluminum fluoride was used? So what is it saying? It's saying that we don't know how much aluminum fluoride was used. So now we have to do substitution again. You know you started with 25 grams, so you replace the little substance here with the number 25, plus the unknown number, aluminum fluoride, is equal to what? You have 35 grams plus 7 grams like this, right? So you're doing the same thing. So this right-hand side is equal to what? 42 grams. So how do we get 25 grams off to the other side, right? So what is the opposite of addition? It is subtraction. So what is this unknown number? This unknown number is going to be 17 grams. You can do a quick check. 25 plus 17 is what? 42. And then 35 plus 7 is also 42. So you know you did this right. So what is this? If we wanted to like really label this, right? This is F2, and then this one was AlF3. Okay, so one last type of example here. It says if 6 grams of chlorine, so this is our reactant, reacts with 8 grams of aluminum fluoride, what is the total products, so already combined, that was produced? So then here, you are just going to do some quick addition, right? So 6 plus 8, remember these are our reactants, is equal to our products. So what is 6 plus 8? 14. 14 grams of products then is our answer, okay? So that's how you do conservation of mass. Whatever you start with, reactants has to equal all of your products at the end, okay? Okay, so now let's learn how to balance chemical reactions. So there are a few steps that we need to follow here. In order to balance a reaction, you need to have an equation with all the chemical formulas written correctly, okay? You have to see how many of each element you have on both sides of the equation. We are gonna write coefficients in front of these compounds or elements until the total count is the same on both sides, okay? So we basically have to multiply to get to a certain number. I'm going to show you how to do that with these simple examples right here, okay? There are several ways that you could do this. You can count it and write it down. You could do it in your head. You could write little side notes, sort of up to your style, okay? So I'm going to show you a couple different styles here, but you can definitely come up with your own. See this arrow here? This reaction arrow tells you that whatever's on the left, this is your reactants, has to equal whatever's on your right, which are your products, okay? So what some people do is they'll write the available elements down this arrow. So for example, there's a sulfur and there's an oxygen. So they'll write an S and they'll write an O, and then you'll have the same sulfur and oxygen on the right-hand side. Obviously they look different, but same elements, okay? Then you can count to see how much you have in the moment, okay? So for example, I have 8 sulfurs. So I put an 8 here, and then I have 2 oxygens, so I put a 2 right here. Then I count the right-hand side. How many sulfurs do I have here? Well, there's no number, so that implies a 1. Then how many oxygens do I have here? 3. Then you ask yourself, is this conservation of mass? Do I have the same number of elements on both sides? The answer is no. So then you have to put coefficients to make them equal. So let's look at this first option here, okay? Right here, you want your sulfurs to be equal. So you can't go down in number. You can't just subtract off, right, elements. So you only can go up. And the only way you can go up is multiply going up. You cannot add, okay? Only multiply. So when you see these coefficients here, you got to imagine that there's a multiplication symbol here. The multiplication symbol is not actually there, but we put it there just so that it reminds you to multiply. So you're going to ask yourself, like, what number should go in here that multiplies by this imaginary 1 that will get me to 8, right? So what times 1 equals 8? Then most of you would say 8 times 1 gets me to 8. So I don't have any 1 anymore. I now have 8, right? So now that I have 8, right, this is now equal. We're good. But check out what you just did. When you wrote an 8 here, okay, you changed this sulfur, but you have to always check what other elements you are changing. So 8 times 3 here, right, 8 times 3 is 24. So you don't have 3 oxygens anymore. You now have 24 oxygens, right? So now you're thinking, okay, my oxygens are not balanced. I have 2 on the left-hand side of the arrow, but I have 24 on the right. So how can 2 become 24? What number am I going to multiply with? So what number should go here multiplied by 2 that gets me to 24? So you're like, what times 2 equals 24? You can think about backwards, right? 24 divided by 2 is 12. Right? So now you do a quick check. I have 8 sulfurs on both sides and I have 24 oxygens on both sides. So now it's balanced. So some people ask, well, what about here? You can leave it blank, but if it bothers you, then what number is always implied when it's blank? A 1. So you can leave it blank or you can put a 1. Either or, it doesn't matter. Now, for some of you, doing all that counting is like complicated. You're like, I don't want to write anything. So if you don't want to, you don't have to. Okay, so let me just show you an example of where you're just doing it in your head. Okay, so here's the arrow. That's where you always want to check. So everything on the left has to equal everything that's on the right. So you do a quick check. You have 2 oxygens on the left, but you have 3 oxygens on the right. You're like, oh, that is not equal. You know your only option is to multiply going up. So you can't just add 1. That doesn't make sense, right? So 2 and 3 can both multiply up to what number? Like most common factor here, right? 2 and 3 can multiply up to the same number, which is what? 6, right? So you want 6 of each one. So what number times 2 will get me to 6? So you're like 3 times 2 gets me to 6. So I now have 6 oxygens on the left. So what number times 3 will get me to 6? And you're like 2. Okay. So you can make like scratch notes, like, you know, notes to yourself here. You're like, okay, I have 6 total oxygens. I have 6 total oxygens. Good, right? But the coefficients are 3 on the left and 2 on the right. Now, remember that when you put a coefficient, you always have to check to see if it affects any other elements. So you're like, oh, this 2 has to multiply by this 2. So how many irons do I have? 2 times 2 is 4. So you're like, okay, I have 4 irons. Over here, I only have 1. So what number times 1 gets me to 4? 4. So if you want to work it that way, you can just do it mentally here. You're like, okay, I have 4 irons on both sides. I have 6 oxygens on both sides. Okay. So once again, I'll show you another example where I write out all the work and another example where you're sort of doing it in your head. So you can do what you want here. So here we go. If you have arrow here, this is where the left has to equal the right, reactants equals products. You check to see what elements you have. So I have a hydrogen and I have an oxygen. So I'm going to do a quick count. I have 2 hydrogens on the left. I have 2 hydrogens on the right. I have only 1 oxygen on the left, but I have 2 oxygens on the right. So you're like, oh man, not balanced. Have to balance it out. So my oxygens are not balanced. So you got to fix this first. This 1 needs to be multiplied up to a 2. So total of 2 is my goal. So you always think to yourself, okay, what number times 1 gets me to 2? And it would be 2. 2 times 1 is 2. So 2 times 1 equals these numbers down here, which is the 2. Now remember that every time you put a coefficient here, you got to ask yourself, did I affect any other elements? So 2 times 2 is what? I don't have 2 hydrogens anymore. I now have 4. Okay, so I have 4 hydrogens that I need to deal with. So now it's not equal. So now my goal is I don't need 2 hydrogens. I need a total, right? Total of 4. So you have to ask yourself, what number on the right-hand side times this 2 will equal 4 over here? Okay, so what number times 2 equals 4? So you're like, 2 times 2 equals 4. So then what's the answer? It's 2, 2, and right here you can leave it blank, or you can put a 1. Okay, and that's how you would do it if you want to write out all your work. Okay, one more example if you're just doing this inside your head here. All right, so you just sort of think about it, like, okay, I see that I have 1 K on both sides, equal. 1 chlorine on both sides, equal. Oh, but my oxygens, I have a 3 here and I have a 2 here. Oh, it's that one where it's not the same. So like, okay, I can't add, I cannot add, so I have to multiply going up. Both of them have to get multiplied up to the same number. Okay, then what's my goal number? My goal number, you can write it down or you don't have to, is 3 and 2 both multiply up to what? 6. So 6 is sort of like my scratch work here. My goal is to get to 6. So what number, right, times 3 is going to get me to 6? What number times 2 is going to get me to 6? So I'm going to put a 2 here. 2 times 3 is 6. I'm going to put a 3 over here. 3 times 2 is 6. Now, putting a number over here, this 3 doesn't change any other element, so I'm good here. But putting this 2 here affects other elements. When I put a 2 here, I now have 2 Ks, potassium, and I now have 2 chlorines. A coefficient affects every number in the compound, right? So now I have 2 Ks and 2 chlorines I need to worry about. But over here, I see that I only have 1 of each. But if my goal is 2 of each, right, then what number do I need to put here to multiply by each of these to get 2 instead? Then you would be like, oh, I need to put 2 here because 2 times 1 is 2, 2 times 1 is 2. So what is the answer to this problem? It's 223. Some of you, like I said, can do all of it in your head. Great. Okay. If not, I highly recommend writing it out and counting it out. All right. We'll do some more practice.